What is going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to see how we can calculate the nth power of a real number and the factorial of an integer using recursive functions or recursion. Now for the libraries we're going to include the C standard library, so stdlib.h, and then we're also going to include the stdio library, and we're also going to include the math.h library. Now in this case I'm not really sure if we're going to be using the math.h library, but because we're going to be doing some math, so it's better to include the math.h library. Now every C function is going to have a main function, so the return type of our main function is going to be int. And here we're going to declare the main function and also define the block of this function by those curly braces. So we also need to create a function. So we'll first of all look at how we're going to calculate the nth power of a number using recursion. So we need a function here. So now the return type of this function is going to be double. Now you can also use float, right? You can also use float there. And then here we're going to say nth power, that is going to be the name of our function. And the function is going to need two pieces of information. So we need to provide the base. Now the base is going to be a real number, but we're going to just say double here, double, and then here we're going to say base. And then we also need an exponent. Now the exponent is going to be an integer value. So here we're going to say int exponent, right? So now those are the two pieces of information this function is going to need. And now whenever you are using recursion, you would need to provide what is known as the base case. Now what is going to be the base case? Now we know that any number raised to the power of 0, so any number except 0 raised to the power of 0 is going to be 1, right? So what we're going to do is, that is going to be our base case. So we need an if statement here. So here we're going to say if the exponent is going to be equal to, now here we're not going to use a single equal sign because we're not assigning the value to n. We're trying to check or to verify if n is equal to 0, and so we will need two equal signs. So here we're going to say if n is equal to 0, then we are supposed to return, so what we're going to return a 1. If n is equal to 0, we're going to return a 1. Now that is okay. Now the else part is going to contain the implementation. Now what are we going to do if n is not equal to 0? So well, we need to calculate the nth power of the number, right? So for example, if you say for example 2 to the power 3, we're going to multiply it to 3 times. So a recursive function is going to be a function that within its block is going to call itself. Now we normally are going to call our functions in the main function, right? But we know that we can also call functions inside other functions apart from the main function. Now this, for the recursive type of function, or for recursive functions, the function is going to call itself within its block of definition, or within the block of the function. The function is going to be able to call itself. So here basically we're going to return. So here we're going to return. So the function is going to call itself. So here we're going to say return nth power, but here first of all we have to say base multiply. Now I'm going to explain this logic in a few seconds. So here we're going to say base multiplied by nth power. Now the function is calling itself here, so nth power, and now we'll pass in the same base. So we'll say base, and then we're going to reduce the exponent by 1. So here we're going to say exponent minus 1. So what is happening here? So for example, let's say we have 2 to the power 3. So we can say 2 to the power 3 is equal to 2 multiplied by 2 to the power 3, right? For us to be able to 2 to the power 3 is equal to 2 multiplied by 2 to the power 2. So for us to be able to calculate 2 to the power 3, we first of all need to know what 2 to the power 2 is going to be. For us to calculate 2 to the power 2, we also need to know what 2 to the power 1 is going to be. Now this is going to be the meaning of this logic that is here. So we'll be calling the function each time we need to calculate 2 to a certain power. Now imagine that we're going to imagine that 2 is any real number, and then we're going to also imagine that the exponent is any integer value, right? Now this is how the logic is going to work here. So That is okay. So we have our base case defined, which is okay. Now n, we don't know n. So here we're supposed to say if int exponent, so we don't have n, but we have exponent. So we quickly have to fix that problem. Now everything is okay. Our base is defined and our function is looking pretty good. So what we're going to do is we're going to go in our main function and then we're going to try and see if our function is working correctly, right? So here we're going to tab a little bit and then here we're going to declare, we're going to say double and then let's have double. And then let's just say we have double value is going to be equal to, now let our base be equal to 2, right? And then we're going to say, well, int exp, we want our exponent to be equal to 3. Now the result has to be 8, but remember that the return type of our function is double. So we're going to get some zeros after the decimal point. So we'll probably need to trim off some, some zeros, but that is not a problem. What we need to see before that, the decimal point is an 8. So if we see an 8 now, that is good and our function is working correctly, right? So now we're going to call our function, but first of all, we need to declare a variable here. We're going to call that variable. It's going to be of type double, and then we're going to call that variable result. So here we're going to say double result is going to be equal to, now our function, our nth power function is going to return a value. So we're going to store that value inside a variable, and then we're going to print out the value of that variable so that we get the result, right? So here we have to end that with a semicolon, and now we're going to throw in our value, and we also are going to throw in our exponent. Now we're supposed to see an 8 if everything works correctly. Now I'm going to open my terminal window. Now it's already open. And then I'm going to make it a little bit bigger so that we can see the result. And then here we need to compile our program and we wait for it to compile. Boom, we got no errors. That is good information. So now we need to run our file and right. So we basically get no output. So here we need to, why are we not getting any output? So it's because we've not printed the value of result. So we're not going to quickly get back to our program and try to print the result. Here the value has been calculated, but we've not given the compiler instructions to print the result. So here we need to call our most awesome printf function, and then to this function we're going to provide two pieces of information. So first of all, we're going to terminate that with a semicolon, and then for the second piece of information, we're going to say, okay, we need to print out our result. And then now we need to format our result. So here we're going to say ans, and then we're going to say is equal to, right? And then now you can write whatever you want here to be as descriptive as you want. So here we're just going to say ans is going to be equal to percentage. Now what is the return type of our what is the data type of our result variable? Now it's going to be a double. So we're going to throw in our percentage f here, and now we should see the result on the screen. Now we need to recompile our program because we've made changes to the program. We need to recompile our program before trying to run it. Now we're going to get our GCC nth power, and right, the function, again, the program compiles with 0 errors, and then now we need to run our file. Boom, we get 8. Now that is okay. It means our logic is working. Now we're going to move to our second program. We want to calculate the factorial of a number using recursion, right? We need to calculate the nth power, the factorial of an integer using recursion, right? So now we are going to create a new file. We're going to create a new file in Visual Studio. Now in Visual Studio, that is going to be very easy. You're just going to expand your Explorer. You're going to click on your Explorer icon, and then you're going to click on the new file icon, and then we're going to say factorial, and now every C file has to have the extension .c. Now we're going to hit enter, and that is going to open our file, and we can start typing our code. We can start writing our code. So now for the libraries, again, now in the previous video, in the previous program, we did not use the math.h library. So we're not going to include it here, right? So here, for the libraries, we're going to have the first library. Now the first library is going to be the C standard library. So here we're going to say stdlib. Now that looks okay. And then we're going to throw in our second library, and that is going to be stdio. Now that looks good. Now every C program is going to have a main function. So we're going to declare our main function. So the return type of our main function, once again, is going to be int. Now in other implementations, you might see a void in front. Now what that is going to mean is that the function is not going to be returning anything. So in this case, our function is going to be returning an integer value. Then here we're going to say int main, and then we'll throw those parentheses there, and then we're not going to pass in anything. Now that means that our function is not going to take any arguments. Now in some programs you might see a void here. Now what that means is that we're not going to pass in any arguments. We're not going to pass in any arguments. So now we need to define the block of this function by using our most awesome curly braces. Now we're going to need our function. Now remember, we calculate the factorial that we normally calculate. The factorial is basically the input. The values that we need are integer values. We basically do not use any real numbers. And then we also know that the factorial of negative integers is not defined. So now that is important information, and we also know that the factorial of 0 is 1, and that the factorial of 1 is going to be 1. So we are going to include that in our base case. Now what do you think is going to be the return type of our function? Now since we are working with our values, and now taking the factorial of a number is like taking the product. Now the product of any real numbers is also going to be a real number. So it's best to declare the return type here as integer. Now we know that this integer is going to have a limitation. If you want to get big factorials, you might want to use something like a long int, something like a long int. Now that is going to depend on the requirements of your program. So here we're going to say int factorial, and then we will need to provide only one piece of information here, that is the integer whose factorial we want to compute. So here we're going to say n. We're just going to call the integer n. And what do we need? We're going to need our base case. So it is here that we need to call. And remember our little friend, our dear friend, the if statement, or the if conditional statement. Now, if you want, you can use a switch statement, but it's best to use an if statement. Now, it depends on what you want at the end of the day, and you can do what you want because it is going to be your program. So here we're going to say if. Now we know that the factorial of n, the factorial of 0 is going to be 1. So now here we're going to say if n is equal to 0, we can also say or. Now we're going to throw in our vertical bars. Now or n is going to be equal to 1. Whoa, here we need to say equal to 1. Now what do we need to return? Now the function is going to return an integer. So here we want to return, so 0 factorial is 1, 1 factorial is 1. So here we have to return a 1. We have to return a 1. Now here we can also be very precise, and we can first of all start by saying, okay, if n is negative, now we want to return 0. If n is negative, we want to return 0, right? We can be more explicit. Now it depends on what you want here. Now here you can say if n is less than 0, we want to return 0 because we know that the factorial of a negative number is not defined. Here we need to terminate our return 1 with a semicolon, lest we get any errors at the end of the program. And now this is just me formatting things a little bit better. Now here I'm just going to say else if. Now that looks good. Now our base statement looks okay. Now in the else part, we need to write our logic. That is, if we have the correct information. We have a positive number that is not 0 and the positive number that is not 1, but we would want to compute the factorial of that number. Now let's imagine that we have 5, for example, as our integer, as our input value. Now we know that 5 factorial is equal to 5 multiplied by 4 factorial. Now from there we can generate an expression that is going to help us compute the factorial of 5, for example. So when we want to calculate 4 factorial, we will need to call our function once more. And then now what is going to happen to our n? Our n is going to reduce by 1. Now that is good information. So for us to calculate 5 factorial, we need to compute 4 factorial. for us to calculate 4 factorial, we need to compute 3 factorial. So the case is going to, so we're going to continue branching and branching until we get to 1 factorial or 0 factorial, right? And then we're going to return 1. If we hit negative numbers, well, we're going to return 0 because the factorial of a negative number is not, a negative integer is not going to be defined. So here we want to return, what do we want to return here? So here we're going to return, so we're going to say n. Now here we're going to say n multiplied by, right? Here we're going to say, whoa, now we need an asterisk here. So here we're going to say n multiplied by, now the function is going to call itself. That is going to be recursion. So here we're going to throw in those curly braces, and then here we need to throw in our n minus 1. So for us to calculate 5 factorial, we need to calculate 4 factorial. Now this is the second part of the expression that is there. Now that looks okay to me. And then now we're going to go in our main function, and then we're going to calculate the factorial of 5. So here we're going to say int number is going to be equal to, now I'm going to say int number is going to be equal to 5. And what else do we need here? Now we will need to declare another variable that is going to be int result, because the return type of our function is going to be result. So our output is going to be an integer. So here int result is going to be equal to factorial, and we're going to throw in our number, right? We're going to throw in our number. Now, the advantage of using variables instead of passing in directly our values is that whenever a change is needed, we're going to modify, we're going to make modifications in only one place. Now, that is why we need to make sure that we are always trying our best to use variables. That is good practice. And when it comes to, correcting problems and changing things, you're going to do it much easier and much quicker. And that is going to be good for you, right? So here we need to now call our most awesome printf function. We're going to end that with a semicolon. We need to throw in 2 pieces of information. Here we're going to say that we need to print our result, or not restrict, but result. So here we're going to say result. Right, so we have result, which is a variable. And then here we're going to say ans. Now, formatting depends on what you want and what you want your users to have as, good as information. So we're just going to say ans is going to be equal to, now here we're going to say percentage, and then we're going to say percentage d or percentage I, because we're getting an integer. Actually, there's a better way of formatting this. So here we can say, here we want to say n, and then here we're going to say, first of all, here we want to say percentage d, and then we want to throw in our exclamation point. And then here we will need 3 pieces of information. So we'll also need to pass in our number here. So the number is going, so we'll have number factorial is equal to the result of the computation. Now 5 factorial, the last time I checked, is 120. So we should see 120 on the screen. So now I'm just going to allow myself to open my terminal window. We'll give it, some seconds to spin up, and then we can compile our program. Now it's pretty, wow. So it's there. So now we need to say GCC, and then now what is the name of the file we want to compile? We want to compile the factorial program. So factorial.c, and then the output file, we're going to say we want the output file to be factorial. We want the output file to be factorial. Now, if everything is okay, the program should compile and we should not get any errors, right? And what do we get here? So we say, we get a warning here, type of n defaults to int. Whoa, do you see the mistake here? So whenever this is just a warning. So here we need to throw in our int, because in C, now I work in a lot of programming languages like Python, for example. Whenever we're declaring functions, we don't throw in the data type. Like for the parameters, we don't, throw in the data type of the function, the data type of the variable. But in C, well, it defaults to int if you do not do that. So here it's giving me a little warning that things might actually go wrong. For example, if I want if I have a float, for example, it is going to default to an int. Now that is going to lead to unexpected behavior later on. So now we will clear our terminal and we will recompile our program. Boom, no warnings, no error. That is good information. So we should get 120 to we should get 120 as our output on the screen. Now we're going to get our compiled file, and boom, 5 factorial is equal to 120. Now let's also try another value. I think 6 factorial is 720. So here we're going to change our number now. Notice that because I've used variables in this program, I have to do my modification in only one place. Now here we're going to throw in our 6, and then we're going to save our program. Now what are we supposed to do? Because we've made changes to our program, we need to recompile our program. Now we need to recompile our program. We need to clear our console. Now it's already looking good, so no need to clear our console. It's not bloated, so no errors. Now that is good information, and 720. Now you can modify this program if you want, or you can make changes to this program. You can make it do things that you really want. So it's entirely up to you, the programmer. Now, thank you guys for watching, and I'll see you in the next video.